Wacky Science. Thanks for joining us today. We're going to do some awesome chemistry. First, we're going to take a look at making some moon rocks, and then we're going to make some lava lamps. We kind of have like a space theme going on here, and I like that. The first thing we're going to make today are these moon rocks, and the ingredients that you're going to need at home include a bowl, a measuring cup, some water, food coloring, and if you're really, really brave, glitter. I wasn't really brave. Some baking soda, some vinegar, something to stir with, some clear plastic wrap, and then I'm going to use a turkey baster, but we'll see later that this isn't a requirement. You can be able to do this experiment if you don't have one of these at home. So, in order for this experiment to work, what's going on? Let me fill you in on a little bit of the science behind it. So, in science and chemistry, we have substances that can be classified as acids, which has a pH of less than 7, or a base, which is a pH higher than 7. Well, what happens if the pH is exactly right on the nose of 7? That's something like water. That's called neutral. And when we combine substances that are very acidic or very basic, or the word alkaline is also used for those substances with a pH higher than 7, sometimes we get a cool chemical reaction that happens. And that's what we're gonna strive for today. So the first step is we're gonna take this baking soda and we're gonna pour it into our bowl. The more baking soda you pour, the more moon rocks that you can have to form. It's not an exact measurement. We're gonna have to use our eyesight and our visual cues here in a minute to determine how much water we need or if we need to add baking soda. But right now, I've poured in some baking soda, and I'm gonna put that to the side for just a moment. Next, I'm gonna take some water, pour into my measuring cup, and maybe I'll need more water. We'll play this by ear. And then we're gonna add food coloring. So what color do you want your moon rocks to be? Let's see, today I'm gonna make my moon rocks a little bit of blue. So I'm gonna put some blue drops in there and maybe some green, okay? So mine's gonna be a dark color of moon rocks. I'm gonna stir this together and we can see that my water no longer looks clear, it's very dark bluish green, okay? Next, we're gonna take this water and food coloring mixture and pour it into our baking soda. And what we want it to feel like and look like when it's ready is like snow. So if it's too liquidy, then we're gonna add more baking soda. If it's not liquid enough, we're gonna add more water. So we kind of play it by ear. It's not an exact measurement. I'm gonna pour some in. I poured just a little bit in, and I'm going to stir. Definitely not enough water, so I keep pouring in. Stir it up. And if you're really brave, you can use your hands. I'm gonna get brave right now. So I'm gonna mush it together, and I'm getting closer to that snow-like consistency the more stirring I'm doing. If you find out that your mixture has too much liquid in it, just go back and add some baking soda. And if you find out that your mixture doesn't have enough liquid, then you can go back and add some more water. So when you feel like it's the right consistency, you're gonna make some things that look like snowballs. And so you're gonna smush them together like such, and it should hold together like a snowball would. Then you're gonna take your snowball and wrap it up in some clear plastic wrap. So I'm gonna take this and I'm gonna wrap it up in my ball-like form. I'm gonna set it to the side. I'm gonna go ahead and get my plastic wrap ready for my next moon rock. And maybe I want this moon rock to be a little bit bigger than my last one. So I'm gonna take and smush as much of this mixture as I can And if you want to make it a cool shape, remember when I mentioned if you were brave and you had that glitter? You could put your glitter into the mixture right now as the ball, or you could put the glitter into this water mixture. That would be the point where you'd want to include that. Okay? And so now I have two looking balls again, it was just baking soda and water and a little bit of food coloring. And you're gonna take these and you're gonna place them in the freezer for at least half an hour, okay? And what that freezing will do is to make sure they kind of stick together and hold together in that ball-like form. I'm gonna put these to the side. I have some that I had in the freezer before I came today, and they look like this. They're very cold, okay? And so I have two of them. I'm just gonna do one for now. And this is made primarily of baking soda. Baking soda is an alkaline substance, has a pH higher than 7. Our good friend vinegar here has a pH lower than 7. And so when we have those two meet together, we have a chemical reaction form. So we are gonna take our turkey baster. And again, if you don't have a turkey baster, no problem. You can just pour it on. You can use a pipette. Might not be something you have at home either, but a spoon and pour it over a squirt bottle. All of these are good options, and I'm not able to get my turkey baster in, so I gotta pour. All of these are good options, just so you're able to pour. So I have vinegar here in my turkey baster, and I am going to make some dribbles on top of my moon rock. And my moon rock is fizzing. There's a chemical reaction happening. And my fizzing is going to last a little bit longer because of its frozen status. If I were to try to break apart my freshly made moon rocks, the fizzing would be a lot shorter. So the fizzing will occur as long as a chemical reaction has not happened between that vinegar and baking soda. If the fizzing stops, go back, get some more vinegar, add some more on top. Pretty cool that you can see this chemical reaction happening with just some items that you can find at home in your kitchen. Cool acids and bases. Moon rock's pretty cool. Thanks, everyone. Hi, everyone. Welcome back to part 2 of Weird and Wacky Science chemistry version. And we're going to make a really cool lava lamp today. And a lava lamp, maybe you've seen one in someone's home, and it's this really cool thing where bubbles are moving up and down. And maybe you've never even heard of a lava lamp because you're too young for them, but they're pretty awesome. Here's the materials that you're going to need at home to make this happen. You're going to need an empty water bottle. I'm a big fan of recycling. I stole this from my own recycling container at home. Please drink the water and then reuse it for this cool experiment. You will need some water. You will need some cooking oil, and then some antacid relief. So Alka-Seltzer is the brand name that you might see. I just got the generic version. And then you're also going to need some food coloring, okay? These are the materials you're going to need. I think you can find most of those at your home. And what we're going to take a look at today is specifically how oil and water are not friends. They do not get along. They are, they repel each other and they go away from each other. So 2 new words for you for the day. Hydrophobic and hydrophilic. The prefix hydro means water, okay? And to be hydrophobic, is that you're scared of water. And I'm not saying that cooking oil is scared, but it does not get along with water. It repels and it goes away from it. Hydrophilic means water loving. And so it's a substance that gets along and likes water. Let's talk about this empty water bottle for just a moment. This is made of plastic. The number 1 ingredient in making of plastic is oil. Not necessarily cooking oil, but petroleum-based oil. So remember that oil was hydrophobic, water is hydrophilic, which means that when I drink water, the water is not going to stick to the water bottle itself because the bottle wants to let go of it, and it will let me drink out of it without leaving much behind in it. So we're going to use this, the reaction between the two to see what happens today. I'm probably going to make a mess. What we're going to do is we're going to take our cooking oil and we're going to pour it, about 3/4 of the way full into our empty water bottle. Yep, made a mess. At home, something that could help you pour in a better way would be maybe a funnel or a measuring cup that has a spout on it that will help you pour that in a little bit neater fashion. Okay? So we've used our oil. Our next step is we're going to use, that comes later. We are going to add some food coloring. For this experiment, let's go red. We'll have a red lava lamp today. And so I'm going to add several drops of red food coloring. I'm going to put my lid on for just a minute just to show you what happens when that mixes. We see at the bottom that the food coloring is kind of balled up together. And the reason being is that food coloring is a water-based substance. So it does not like, oil does not like that water, and it's kind of trying to push those food coloring bubbles to their own area. I'm going to fill the remaining part of our water bottle with water. So we're just going to top it off. A little space in there. But as that water settles in, you'll notice that they do a nice job trying to separate from each other. We can see the oil hanging out here. We can see the water hanging out here. We can see that food coloring hanging out at the bottom in that water mixture. Now we're going to make them have a party inside of there. So we're going to take our antacid tablet and scrunch it. Break it into tiny little pieces. Okay? So while it's still in the package, I'm crunching this. And the reason why I need it in pieces, number one, the more pieces, the longer the chemical reaction can go. And number two, I can fit it in the lid of this. And what is going to happen here when we put this Alka-Seltzer tablet in is we've added a new ingredient to our hydrophobic and our hydrophilic ingredients. So I'm going to put some in, and let you watch what happens. So what is happening is it's causing a reaction and releasing carbon dioxide bubbles that are going up into that oil. And it's grabbing a hold of that red food coloring and shoving them upwards so we can see the red dancing up. If you want more dancing to happen, you are welcome to add more food coloring and add more Alka-Seltzer. So the gases you see being released are carbon dioxide, just like what you and I breathe out every day. We can see them going upwards into that oil mixture. Pretty cool. You can make your own lava lamps at home just with some simple ingredients. Now, one thing you'll notice with the bottle is as you're feeling it, the bottle's getting really, really full. And it's because you put the lid on with those gases. If you are comfortable, you can take that lid off. You hear that sound? And the reaction will still happen, but it just won't have that pressure build up on the inside. Still having that lava lamp party in there. So 2 new words today, hydrophobic and hydrophilic. We release some cool carbon dioxide to make a lava lamp. Thanks, everyone.